Alright, welcome back. Okay, now we're going to talk about measurements. I'd like you to take notes on this as far as know what the SI stands for, know how to measure length, width, volume, mass, what tools are used, and I'll highlight everything that you need to copy down. Okay? So why do we use the SI system or the metric system? Well, you can kind of guess just by looking at this. There's so many different methods. We have the U.S. customary standard, and we have the metric system. Well, most of the world uses metrics. The United States is the only one that uses the other system. So in science, since we are universal, we use the metric system. Okay. Length or distance. So length is the distance between 2 points. So there's our section right there. Let's go back. And what do we use to measure distance or length? Is a meter stick, a ruler, or a metric tape. It is millimeters, centimeters, meters, and kilometers. Okay. Oh, by the way, copy that down. For some reason, my pointer is not wanting to work. Let's see, pointer options, highlighter. Okay, so what is matter? Matter is all substances that make up the universe. It has to have mass. Okay, I don't know why it's not highlighting, but please write down that it has to have mass and volume. Atoms are the particles that make up all matter. Remember, atoms are elements also. Okay. Two or more atoms bonded together make a molecule, kind of like what we looked at with water, and it looks kind of like Mickey Mouse. So a water molecule does take up space and has mass. Everything in the universe is made up of atoms and molecules. That's what chemistry is. We're looking at the atoms and molecules and how they react with things. Molecules can be very complex. So, okay. Measuring weight versus mass. Okay, when we're in chemistry, don't say I'm going to get the weight of something. We're going to get the mass of something. Objects that have a weight have to do with gravity. That's something in physics. We're not going to pay too much attention to the weight. We're going to look at the mass. Weight is unreliable. Think of it like this. If you go into outer space, you're going to weigh less. If you go to the equator, you're going to weigh less. If you go underwater, you're going to weigh more. Mass and volume. Mass is the amount of matter or stuff in an object. Please write that down. The tool that we're going to use to measure mass is either a scale or a balance. We either have digital scales or we have the balances. The units that we usually use in chemistry are grams and kilograms, and grams is in red because it's the standard unit. Mass doesn't change due to gravity, so no matter where you're at, you're going to have the same mass. So you're going to use either a scale or a balance. Hint, hint on the test. Volume. Volume is the amount of space taken up by an object. So there are different tools depending on what we're looking at. If it's a solid, we're going to do it one way. If it's a liquid, we're going to do it another way. If it's a gas, it's another way. In plasma, we're not even going to use. But there is another form to do volume there as well. So let's take a look at how we measure volume of a solid object. If it's a box shape or a rectangle or triangle, it has very distinct sides, then we're going to just use length times width times height. Kind of like what you did in math. Okay, so if we were going to find the volume of this box, it would be 12 times 3 times 3, and our unit, and when we're measuring, we're going to have no naked numbers, so we always have a unit. I don't know why this thing is not working, but I'm going to try it one more time. Okay, I want units. Oh, there it goes. Okay, I want units all the time. So our units for a block is going to be in centimeters cubed because we have 1, 2, 3 centimeters, okay, and we're multiplying them. The volume of a liquid. Okay, the tool that we're going to use for liquids is graduated cylinder, and the smaller the graduated cylinder or the more lines that it has here, the better it is for us. The liquid surface curves down and forms a meniscus, and if you look here, we're going to look at the very bottom of the meniscus. Right in here, that is where you take the reading. So if we were to read this volume, it's going to be, looks like 6.1, 2, 3, 4, 5. Okay, so it's 2, 4, 6. So it's going to be 6.8. milliliters. And we are going to use the unit milliliters. Okay? We read from the bottom of the meniscus. It's a curve. How do we do irregular objects? This is something that we have called water displacement. So we're going to basically put it in water. We're going to take the final volume minus the initial volume to get the volume of the object. Okay? So let's take a look at what it looks like. So here's our initial. We have 7 milliliters. It doesn't really matter how much you put in here. Just make sure you know where you start. We take our irregular shaped object, something we can't really find the volume of. We stick it into the graduated cylinder. The water goes up. That's water displacement. So we started at 7. We ended at 9. 9 minus 7 gives us 2 milliliters. And that is the volume of that irregular shaped object. Okay? So again, get your initial, put your object into the graduated cylinder, take your final and subtract them, and you get your answer. And here it is again. 9 minus 7 equals 2 milliliters equals 2 centimeters cubed. So you can, since it's a solid object, you have 2 centimeters cubed. Now, if you want to go into nursing, you would have cc's, cubic centimeters. They're the same thing. So if you hear a doctor say, I need 2 cc's of adrenaline, well, they're talking about 2 milliliters or 2 centimeters cubed. Okay? So the unit is, on this one, like I said, is because it's a solid, it becomes centimeters cubed. Okay. And I believe that's the end, guys. So just take quick notes on this, bring it to class, and I'll see you next time.